Hey guys. Alright, so today we're gonna look at 4-1, solving systems of equations by graphing. Now remember, when we're solving systems of equations, we're looking for a solution, okay? So we typically want to find a solution and we're going to write it as a coordinate or an ordered pair. Alright, so we first want to make sure that both of our equations are written in slope-intercept form. Now, slope-intercept form, remember, is y equals mx plus b. And m is our slope, and b is our y-intercept. Alright, so once both of your equations are in slope-intercept form, we're going to graph both lines, and you want to start at the y-intercept when we're graphing, remember? So the y-intercept is our starting point, and then from the y-intercept, we use slope. Right, after you've graphed both lines, the most important part here is the point where both of our lines are going to intersect. That's our solution. So once you get our solution, it needs to be written as either a coordinate or an ordered pair. Now, a few things to remember are there are some special cases. Now, the first special case is if our lines never meet. Well, if they never meet, they're never going to have a point of intersection. That means there is no solution. Right, the other special case is if the two lines are exactly the same or graphed on top of each other. So pretty much every single point is the same solution, which means we have infinitely many solutions. Alright, so let's take a look at example 1. So we have y equals 5x minus 1 and y minus x equals 3. So y equals 5x minus 1, that equation is already in slope-intercept form. So the second one, y minus x equals 3, we have to put into slope-intercept form because that one is not in slope-intercept form yet. So I'm just going to rewrite it underneath it. Y minus x equals 3. And the only thing we have to do is to get y by itself, I'm going to add x to both sides. So you get y equals x plus 3. So now both of our equations are in slope-intercept form, so we can start graphing them. Alright, so I'm going to start with the top one. So y equals 5x minus 1. Negative 1 is my y-intercept. So that means I'm starting on the y-axis, and I'm going to go down 1. So that's my first point. Now I'm going to look at my slope. So my slope is 5. Remember, slope is always 5 over 1, so we have to make it into a fraction. You put any whole number into a fraction by putting it over 1. So arrive, I'm going to go up 5 from this point. So we're going to go up 1, 2, 3, 4, 5, and then I'm going to go right 1. Alright, so now we're just going to connect these two points. Alright, so now we're going to graph our second line. So our y-intercept here is at 3, so when y is 3, 1, 2, 3. So that's our y-intercept. Now our slope, now remember, if there's no number or coefficient in front of our x, then we can always put a 1. So our slope is just 1 over 1. So we're going to go up 1 and to the right 1. And we can keep going in both directions. Now remember, when we're going in the opposite direction, because we're creating line, we have to go in the complete opposite way. So instead of going up and to the right, I'm now going to go down and to the left. Right, and now we can draw a line through these points. Now when we look at our graph, there's this point here where both these lines overlap on top of each other. So that is our solution to the system. So we just have to figure out what coordinate that is and write it as a coordinate. So it looks like when x is positive 1, our y is 1, 2, 3, 4. So our solution is 1, 4. All right, so let's look at example 2 now. We have negative x plus y equals 1, and then we have x minus y equals negative 3. All right, so neither of these are in slope-intercept form, so we need to rearrange them in a slope-intercept form. I'm going to start with the first one, and I'm going to just rewrite it. And we want to get y by itself, so all we have to do here is add x to both sides. So we get y equals x plus 1. That's our first equation we're going to graph. All right, so now let's look at the second one. I have x minus y equals negative 3. Subtract x from both sides. Negative y equals negative x minus 3. Now the difference here is there's a negative in front of y, so we can't leave y negative. So in order to get rid of that negative, I'm going to put a 1 in front, and we're going to divide everything by negative 1. That's going to help me get rid of the negative, because negative divided by negative is positive. So we're left with y equals positive x plus 3. Alright, so now we're ready to start graphing. So my first equation, my y-intercept is at 1. So we plot our first point at 1, and my slope is also 1. So we go up 1, right 1 in both directions. And then we can draw our line. And now we can graph the second equation. So my y-intercept's at 3. So we start at 1, 2, 1, 2, 3. And my slope is also 1 over 1. So we go up 1, right 1 in both directions. You can keep going if you want. I just stopped at a few points. And I'm going to draw my line. Now, our points never intersect. So they never intersect, so we have no solution. Which, if you remember from Friday's work, you just have to look at the slope. If we have the same slope, then we should know that there's no solution. All right, so example 3, we have 3y equals 2x minus 3. And then we have 3y minus 2x equals negative 3. All right, so neither of these, again, are in slope-intercept form, so we're going to rewrite them and put them in a slope-intercept form. And so in order to get y by itself for the first one, it's being multiplied by 3. The inverse of multiplying by 3 is dividing by 3. So we're going to divide everything by 3. We get y equals 2/3 x minus 1. And then if we look at our second equation, well, 3y, y is being multiplied by 3, but it's also being subtracted by 2x. Remember, we have to use PEMDAS backwards, so we're going to start with subtraction or addition. So I'm going to move the 2x, negative 2x over first. So we're going to add 2x to both sides. We get 3y equals 2x minus 3. Well, now I also have to divide everything by 3. So get y equals 2/3 x minus 1. Now you can see here that both of these, we get the same line, okay? So I'm going to graph them both just to see. So we start at our y-intercept, which is negative 1. Our slope is 2/3, so we go up 1, 2, right 1, 2, 3. And then I'm going to draw my line. Well, now I'm going to do the same thing with the second one. My slope, or my y-intercept, is the same at negative 1. My slope's the same at 2/3, so we got 2, right 1, 2, 3. And we're just drawing over the same exact line. So when that happens, when we're drawing on top of the same line, that means we have an infinitely many solutions. That's it.